This video will be on proportions and similar figures. And the first thing we need to discuss is what are similar figures. They are figures that have the same shape but not the same size. Nice easy example here, two triangles that have the same shape, but they're not the same size. Next thing we can talk about is what is the symbol for similarity. And the symbol that we're going to use is this little swirly line, call that a tilde, but that stands for similarity. So if these two triangles are similar, we then could say that triangle, and this is a symbol for triangle, A, B, C is similar to triangle F, G, H. Now in similar figures, they have some unique properties. It turns out that all of the corresponding angles are congruent. So angle A corresponds to angle F, so we can say that angle A is congruent to angle F. This is the symbol for congruency, and congruency just means the same measure. So angle A corresponds to F, angle B corresponds to G, and angle C corresponds to angle H. So in similar figures, all the corresponding angles are congruent, or the same measure. Well, it turns out that corresponding sides are also proportional. So if we take this side over here, which is AB, side AB, and place it over the ratio of its corresponding side, FG, so AB, FG, it would be in the same ratio as any other side, let's say AC, and the corresponding side to AC, which is on the outside, would be F and H, FH, which is over here. And we could also say BC corresponds to GH. Because of this statement of similarity, triangle ABC is similar to triangle FGH, we have to make sure that angle A always matches angle F, B always matches G, C matches H. If at any point B matches either F or H and not G, then we're talking about two different triangles that are probably not similar. Now let's go ahead and see that these ratios are actually the same. We'll take AB first, which is 8, over FG, which is 12. We'll check to see if that's equal to AC, which is 10, over FH, which is 15. And the first thing you want to notice is the top numbers are smaller than the bottom numbers, so at least we are in the right track. And the way we check to see if two ratios are equivalent in a proportion is to cross multiply. So 12 times 10 gives us the 120, and then 8 times the 15 also gives us 120. Now let's compare this one to BC. BC is 12 and GH is 18. We'll cross multiply those. 15 times 12 gives us 180, so the cross product here will give us 180. And 10 times 18 will give us another cross product of 180, so you can see that these ratios are still the same. And if you wanted to, you could do 12 times 12, which is 144, and 8 times 18, just double check that, should also equal 144, and it does. So all these sides are in proportion. Okay, so let me show you how we can use this. We're going to say that triangle ABC is similar to triangle DEF. ABC to DEF. Those are the corresponding sides. The question they're asking here is, what is the length of DE? DE is this length right here. I don't know what that measurement is, so I'm going to call it N. And I'm going to start with N in my numerator and ask myself, DE, which is here, DE, which side does it correspond to in the other triangle? Well, sometimes you can tell just by looking at the triangle. However, you can always tell just by looking back at the similarity declaration. So DE is here, and that would match side AB, which is 10. Now we got to be careful how we set our ratio up. We'll call this triangle 2 and this triangle 1. So the way I set this up was I had triangle 2 over triangle 1. So in my other ratio, I have to have triangle 2 over triangle 1. So go back to triangle 2 and pick another side, EF or DF, and it doesn't really matter which one you want to use. However, in this case, I can't choose DF, because if I look at AC, which is the corresponding one, I don't have a measurement there. So I actually have to use EF in this case. So EF is 12, and EF corresponds to BC. So B and C would be 16. And there's your proportion that you can use to solve for the measurement of side DE. So N times 16 is going to give you 16N. And 10 times 12 is going to give you 120. And to solve this proportion, or solve this equation, we're going to divide both sides by 16. 16 over 16 is 1. 1 times N is N. Please use a calculator here. So 120 divided by 16 tells us the length of DE is 7.5 units, whatever those units are, millimeters, feet, miles, doesn't matter. So that's how we can solve missing parts of similar figures. We can also apply it to other things like indirect measurement. Okay, so we've got a building here, we've got a person standing near the building, and the question is, how tall is the building? Well, somewhere out here we have the sun, and the sun is shining down, and the rays hit the top of the building and stop out here, creating a shadow where the sun is actually not hitting the ground. Well, as long as this person is standing near the building at the same time of day, they will have a shadow that creates a right triangle that is similar to the triangle or right triangle created by the building, where one of the legs is the building, the shadow is another leg, and the hypotenuse is this imaginary beam of light that comes down. So the triangle created here would be similar to the triangle created here, so we want to know what's the height of the building. Well, the height of the person corresponds to the height of the building, so we're going to put height of person over height of building. And we're going to let that equal, since I started with the person over building, I got to do person over building ratio on this side. Shadow of person over shadow of building. Okay, so the height of the person is going to go here, which is 5. The height of the building, I don't know what it is, so I'm going to put X. The shadow of the person is 3 feet long, and that corresponds to the shadow of the building, which is 15. And to solve this proportion, we're going to do as before, we're going to cross multiply and divide. So 3 times X is going to give us 3X. And that cross product is going to give us an equivalency to 5 times 15, which is 75. Now remember, this is in feet. So we're going to divide both sides by 3. 3 over 3 gives us 1. 1 times x is x. And 75 over 3 gives us 25, and the units were feet. So a person that's 5 feet tall casts a 3-foot shadow. At the same time, a 25-foot building will cast a 15-foot shadow. So the height of the building in this case would be 25 feet.